Alright, ladies and gentlemen, we got 2.5 addition and subtraction properties. Now, we've probably already talked about these a bit in class and kind of use them here and there, but we're going to formally introduce them in this riveting and exciting video for your viewing pleasure. Alright, so the general idea here for addition property, we're going from small to big, and subtraction, we're going from big to small, and I think it would be helpful if we drew something out here, so that's what I'm going to do. Alrighty. So let's say I've got this. This will be a familiar diagram at times. What if I've got these two angles congruent? So we'll say this is A, we'll say we got B, C, D, and E. Ooh, that's Mr. Allen's lunch there in the microwave. But you know what? Geometry is more important. So I'm going to keep rolling here. Okay. So we've got angles CAB and DAE are congruent. Now, is there anything else I could conclude? Well, let's think here. If I were to add the same angle to both, I'd get two larger angles that are congruent. So addition property for this one would be angle BAD is congruent to angle EAC. That's exciting stuff right there. I just added angle CAD to both of them. Now, I don't put that in my proof, but that is what's going on behind the scenes. So I'd say that those two are congruent, and my reason would be the addition property. Now, let's think about this as a subtraction property type problem. I'm going to draw a similar diagram. Let me make that a little smaller here. All right. So let's say I've got the same type of diagram, and I'll even label it all the same. Okay, so we've got B, and we've got A right here, C, D, and E. Okay, that's D. Perfect. All right. Well, let's say that I'm given BAD, angle BAD is congruent to angle EAC. Okay. Is there anything else I could conclude? Well, let's think here in the context of subtraction, right? We're going from big to small. So right now, what I've got is, okay, so I've got this angle is congruent to that angle, right? Well, what if we subtract something? What if we subtract the same angle? So I'm going to do a little erase here. Ooh! Did I just erase the same thing from both those angles? I did. Do I have two new congruent angles? I do. So with subtraction, I can get angle CAB congruent to angle DAE. I'm subtracting out angle CAD there from both of them, resulting in two new ones. Okay, so subtraction property for that bad boy, right? That'd be my reason, would be subtraction property. Okay. This will also work if we were to add for addition property or subtract for subtraction property congruent angles from congruent angles. And we'll see that going forward here. But that's just a little preview, little snippet explanation of these two awesome properties in which we'll be using. Oh, snap. Proof? There it is, as they say on the streets. Right, on the streets of geometry. So we got ourselves a proof here, example 1. Let's see what we got going on. So we're going to make some congruent marks here on this bad boy. I've got angle NOP, and it could get a little messy here, so I'll do my best here with I'm writing with my finger, which is kind of difficult sometimes. All right, NOP, which is this guy right here, is congruent to NPO, which is this guy over here. And then I've got ROP, so that's this. I'll put a little tick mark on it. And RPO. So that's what I know, okay? But what do I want to prove? I want to prove that NOR, I'm going to do this in red. This is like my want. I want to prove this guy is congruent to this guy. Ooh, how could I do that? Well, first off, I got my given, and I'm definitely not going to try and write all this out with my finger here. So I'm going to go ahead and draw an arrow, because rewriting, ain't nobody got time for that. especially when writing with your finger on this software. Okay. How would I do that? Well, I've got NOP and NPO congruent. I've got those two smaller angles congruent. What if I were to take that away, meaning subtraction? If I were to take, let's see here, if I can get a laser. Oh yeah, laser. All right, if I were to take this angle away from the big angle, I would be left with NOR. Oh. And if I were to take RPO, whoop, there we go. RPO away from NPO, I'd be left with NPR. Oh, that's dope. Sounds to me like we've already got ourselves a proof. All right, so angle NOR is congruent to angle NPR, subtraction property. And I'm cool with abbreviations, but I will warn you, subtraction property needs to be SUBT, because SUB could also be confused with substitution property, which we have yet to learn. So make sure you differentiate there, all right? America. Alrighty, so we've got J and K are trisection points of HM. GH and MO are congruent. We want to conclude that GK and KO are congruent. Alright, we got a bit going on here. So GH and MO are congruent. I'm just gonna go ahead and jot that down. I know, it's a sweet voice crack. I could start over, but I'm going to leave that in there for your enjoyment. J and K are trisection points of HM. What does that tell me? Ooh, I'm going to use 2 tick marks for this now because that's just going to be easier. All right, that means that all 3 of these are congruent. Awesome. And I want to prove that GJ and KO are congruent. So let's look. I've got these 2 congruent parts, this GH and MO, and I've got HJ and KM. Well, if I take 2 congruent pieces and add 2 congruent pieces to those congruent pieces, I believe I should get congruent pieces. In other words, congruent segments are the pieces that I'm talking about. Peace out, proof. Sounds like we about done. All right, so we got our given. My goodness, somebody keeps printing in this room. It's disrupting, but I can handle it. I hope you guys can handle the background noise. It's gone. Okay. So let's see here. We got a couple things. I know that HJ is congruent to KM, and it's also congruent to JK, LOL. I'm just going to toss that in there because, so we could have all 3 of them. Since trisecting, would say that we get 3 congruent segments or 3 congruent angles, I'm going to put all 3 in there. But you don't necessarily have to. You can just do the ones that you're talking about, which would be this guy and this guy. Okay? And then, make sure we have a reason. Definition, trisect. And then we've got, I think we're already at our proof, right? Because all we're going to do right now is we're just going to do some addition. So, addition property, add prop. So, we've used addition and subtraction in the past, but not totally in this context where we're not dealing with real values. Before we were dealing with values like angle measures or segment measures. Now we're dealing with more like an arbitrary value. We don't know what that, it's an unknown value. We just know that they're congruent, right? So we're putting congruent parts together or taking congruent parts off of congruent parts, whether those parts are segments or angles, right? So it works with both of those. Awesome. Maybe we'll see something like that here in the future. All right, we got this this beautiful problem here with an angle. It's just almost like I knew what was coming next. Like I can see the future. Okay, yes, I can see the future, children, because I have a Costco membership, which means that I'm elite. All right. So angle BAD is the right angle. I'm going to jot that down, dog. Pew, pew. I know that CA is perpendicular to EA, or AE. Doesn't matter. What does that tell me? Oh, right angle, YOLO. And I want to prove that BAC is congruent to EAD. BAC, I'm going to put that in red, EAD. I want to prove those two angles are congruent. All right. I have this strange feeling that it's going to somehow involve addition or subtraction property when dealing with these angles, right? I mean, that is the section that we're in, so that would make sense. I'm going to go ahead and move this bad boy up so we got a little more room to work. Okay. So when we're dealing with addition or subtraction, we're talking about, okay, I want to prove some angles congruent, and I want to take something away or put something, add something to it, right? Well, what do I know about BAD and CAE? Well, if they're both right angles, then they're congruent, right? So I'm thinking that's going to be in my proof here, and if I get those congruent, what could I do? Oh, you know what I could do? Check out this middle portion here. I'm going to put this in green because I like green. That's why I got green Timbs. If I take that piece away from both of those congruent angles, I've got what I want in red there, right? Okay, let's write her up. So I got to say first that angle CAE is a right angle. And that's my definition of perpendicular, right? Got to state that. Don't forget these things, because as you get rolling, you might forget to write something in there that you were just thinking. You forgot to jot it down. You got to write it down. Okay, so now I've got BAD and CAE are right angles, so I can say that angle BAD is congruent to angle CAE. All right angles are congruent. So if those guys are congruent, and I take away CAD, what am I left with? Woo! Angle BAC is congruent to angle EAD. And what property did I use? Well, I went from big to small, so that'd be subtraction property. America. Hashtag. Nice work, children. You guys did an excellent job there. Not that I could see it, I could feel it. Okay, I could feel it through the interwebs that you were doing awesome. All right, so we got some issues here on this one with how it all imported. Looks like our congruent symbols floated away with the technologies. Like that guy, it needs to be whoop, up here. Okay. Hopefully that makes sense now. So I've got angle HEF is supplementary to angle EHG. Okay. And then GFE and FGH are supplementary as well. And then I got a couple sets of congruent angles. So let's organize this a bit, all right? I'm going to put down my congruent parts first. So EHF, and then FGE. So these two are congruent. And then we've got GHF and HGE. Okay. And I want to prove HEF, I'll put that in red, and GFE. Right? I want to prove those two are congruent. They aren't congruent, but I'm going to prove that they are. Then I got this whole supplementary business. I'm going to put that in green, okay? We're going to put the supplementary biz in green. Now, this isn't necessarily official notation, but I'm going to do it anyways because I'm a, make my own rule kind of guy, right? I live a pretty rogue lifestyle, if you will. I'm not going to handle this kind of thing. So HEF, I'm going to say is sup, I'm going to put an S there, to HEF and then EHG, which is this guy right here. Let's say that those guys are sup, right? I'll put an S there on like a congruent tick. They're not congruent, they are supplementary. And then we've got GFE. I'm going to put 2 with an S. And then we've got this bad boy right here, right? Okay, FGH. Yep, there we go. That works. Okay. Well, I seem to remember a pretty dope theorem that we've learned recently about subs of congruent angles and subs of the same angle type deal. Well, let's see what we can do. So, for fun, I think it's sometimes helpful to work backwards, okay? And by sometimes I mean actually oftentimes it helps work backwards. I want to prove that these two are congruent, right? Well, these two right angles are supplementary to these two angles, right? This angle here and this angle here. So if in theory I was able to prove that these two angles were congruent, I could say that sups of congruent angles are congruent. Ooh. Well, is there a way that I can get these two angles here to be congruent? I sure as heck think so. Okay, I think it's time we start jotting some things down. So that's step one. I'll write my given. Whoop, draw an arrow. Sometimes I forget to do that. Okay. Well, do I know that angle EHG is congruent to angle FGH? I sure do, by the addition property. So although this problem seems pretty intimidating at first with the amount of information we give you, that given really helps out with all that stuff, right? You just got to be able to organize it. So I think I'm actually already at my proof. I've got EHG and FGH congruent to each other. I've got the supplementary aspect going, so I can say that angle HEF is congruent to angle GFE, and that would be sups of congruent angles are congruent. Sups of congruent angles are congruent. There are different ways of writing this. That's one of the short ways that I've done. But there are different ways of describing that theorem, but they all are kind of similar to each other. All right, awesome, great, grand, wonderful. All right, so I'd highly suggest taking a look at that awesome, super cool homework, and we'll have a quiz here shortly after a few sections. You know what I'm saying? America, freedom, rock and roll.